to something like pointers. So at that time we have to first change the declaration, and the declaration would be something like, we have to specify that this is a pointer. Now one more thing here I would like to mention is, you need to read any pointer variable from right to left. Okay, so if you say something like I'll just write some int pointer j. So here you will read this pointer as j is a pointer variable which is pointing to an integer. Okay, so here you can say that, here if you say here you are passing some other value, at that time you need to reference it as it is a j is a pointer which is pointing to an integer. Similarly, if you write char, you have to write something like char pointer j. So you will read this as j is a pointer variable pointing to an character. What does this change the address, or does this change the data or size of your pointer? No, it doesn't change the address size, but what it does is, if you are pointing to an integer, so the next, if your integer is of 4 bytes, at that time the next pointer, when you increment the pointer variable, it will point to the next 4th byte. That means if you are pointing to somewhere like 1000, your pointer is pointing to the address location of 1000, then when you increment your pointer variable, it will point to 1004. Next is 1008. Similarly, if you say char is of 1 byte, at that time your address will be, when you increment your pointer, it will point to 1001, 1002, and so on. So basically, when you specify what is an integer pointer or character pointer or float pointer, the next address location it will point, that does matter. Now what happens if you are specifying char pointer and you are using it for integer? At that time, as it is a char pointer, what will happen? You will not be able to access the integer value. Why? Because your integer is of 4 bytes and char is of 1 byte. That means if you are writing, if you are storing some value like 4, 5, 6, 7, at that time it will not access this 4, 5, 6, 7 at a time. It will be divided into something like 1 byte, 1 byte, 1 byte, and 1 byte. So here you will get some garbage values. So it's better, whenever you are using a particular data type, you have to specify that particular pointer variable.
Okay.
So this is the importance of specifying what is your type of pointer variable, because you may have everyone will may have said that it is a simply address. Yes, it is an address, but when you change it or when you increment it, it will point to that particular data type. Okay, so here always read this from last, right, which is j is a pointer variable. J is a variable which is a pointer and it is pointing to an integer. Similarly, if you have some other variables, you can read it in same way. We will see that in coming programs. Okay, and we will write one more program where we will try to access just now whatever we have said. We will try to access that. So we have written previously, we have written one pointer program. So I'll just edit that program. I'll show you what just now whatever I have said.
No.
I hope your Ubuntu is working perfectly in VirtualBox. Better to practice it in VirtualBox only, or in your system if you have dual boot system. You are not audible, so please, if I am not audible, do specify just that I am not audible, or just ping me. Okay. So we'll just gedit is one of the editors. So gedit, we will just pointer one dot. Now we will try to use this. It's better we will write another program. Okay, we will write here one more. I am taking one more variable called char. I am specifying it like q. Char q is equal to something like a, and we will use this value. Now we will simply place in your integer variable. So at that time I'll just specify it as q. Okay, so j is an integer pointer and q is a char pointer, or else we will just change it to this as int only. Int I is equal to 5, and we will simply make this as char. Okay, so this is a char variable now, and we are using integer to fetch the address of I, and we will just print this value of I. Now what happens, because this is an integer pointer, so whether it is working properly or not, we will just see this now. Okay, so here your variable is I, but your pointer is an integer pointer. We will see both the things, that if at all, if pointer is a integer pointer and variable is I, as well as vice versa. Okay, so GCC So here already it has mentioned, here it is showing us, it is showing a warning for us that here it is an integer pointer and it is an incompatible type with this. J is equal to ampersand I, because I is a character variable and J is an integer pointer. Okay, so we will just dot slash, it's just a warning, so we will try to execute it. See, I is equal to 97, address of I is this. Okay, this is proper. Okay, why it is not showing any error is because A value is 97, that is fine, value of I is 97. Now we will just do the vice versa thing. It is trying to fetch 4, 1 byte is assigned to A, rest of the bytes are zeros, that's why it is not throwing any error. Now here we will change this to char pointer, and here we will change it to int. Okay, now our pointer is a character pointer and our variable is an integer. We'll compile it once again. So here again we have warnings saying that this is an integer pointer, and sorry, char pointer, and this is an integer pointer. We have warnings. So again we will just, now here also again we are able to fetch this value. Why? Because your character pointer is pointing to here your, if you have some other big value, at that time it will throw errors, otherwise it is showing okay. Why? Because your integer is A value is 97 and char is able to fetch. Now if you increment this variable and if you will try to see the next value, at that time it may throw errors. Okay, that we will see in arrays otherwise. Okay, but the point is that if you are specifying, we are not incrementing any pointer variable right now, but if we increment the pointer variable and you are assigning integer to character or character to integer, it may throw errors. It will give you warning, so accordingly we can just change it. Okay, now coming to your function again. So we have that function where we were passing it with that thing again we will see. Okay, in what we have when we use arrays, we will do it right now. So when we are going with arrays, at that time we will have to increment the pointer variable, which might be char or int, and there we will see what happens when you are incrementing with different pointers. Okay, so here now we will pass your pass by reference. We will use pass by reference now. So first we need to change the declaration stating that whatever we are going to pass is a pointer variable. So here we will simply specify it using this pointer. Okay, and next what we are doing is here also we need to say that this is a pointer variable. So we will simply change it to int x and int y. Okay, so now what happens is when you are passing this variable directly, the changes will be done on your address location. Pointer x plus pointer y. Okay, now we will print this and see what happens. Here also we will try to print this value of c. Print value of c. There we have seen that c value was 0, and now we will see when we are passing by reference what will be the value of c. Comma c. Okay, so here we are printing two values now. One is this and the other one is this one. So here we will see now. It should throw some errors. We will see whether it is throwing or not. So, as expected, this is. So here we have referenced it as integer and it is null. Here these are all warnings except an error that expected declaration or statement at the end of the input which is written z. Okay, rest of it are warnings. We will see that warnings also, but before that we will just check out this one. Okay, now why okay, and now so we have to pass some segmentation fault. Okay, now exactly what we needed. Now what is the segmentation fault? Segmentation fault, this is again an interview question. Segmentation fault is when you are trying to access the memory which is restricted. That means whatever we are passing, I mean whatever we are using, and if your compiler try to fetch the value outside that particular memory allocated, at that time you get segmentation fault. Okay, it is one of the fault related to memory. If you can simply say that here my range of address is suppose 1 to 10, and you are trying to access something outside that, at that time you get this fault. So we need to check out this fault. Okay, and the other than that, what warnings we do have is passing argument 1 of add makes pointer from integer without a casting. Okay, so here we are passing something which is an integer and we are not casting it. Okay, what is typecasting? I'll show you now. That typecasting is before passing anything, we have to specify what is the type of it. Okay, we will do that now. Okay, we are not going to change it, but what is typecasting we will see in coming program. We have to write that program also, but here what we are trying to do is we are simply passing the values, but what we are doing here is passing by reference. If you are trying to pass it by reference, at that time you need to give address and not the value. Okay, so here we have to add something like ampersand, address of A and address of B. So when you give this address of A and address of B, your pointer X will X is equal to, it is equivalent to X is equal to address of A and Y is equal to address of B. At that time it should execute properly. Now we will see this again. We are getting some errors or any warnings. No errors, no warnings. So now we will see. If you see this value of value of Z is also 8 as well as value of C is also 8. Previously when we passed this previously when we did this pass by value, at that time what happened is, here we were not returning, we were simply returning the value, but C value was not 3 or 8. Somewhere we got this, that one value was not 8, but now if you pass by reference, if you see the value of A and B, here the Z and directly it will be working on A and B values only, and you are returning C. As it is an address location, that's why it will change the value of C also. This is pass by reference. Okay, one more thing we need to see here. If we are not using pass by reference or pass by value, one more keyword we have is static. Now what is that? We will see that also. Once said that, it will be easy. Okay, we will write one more program where I will show you what is this static keyword doing. We will write one program now. We edit. Now we are writing one function. Okay, so we are writing again one add function. And here I am not passing anything. Here I am not passing anything. Okay, so here simply I am writing some normal things like, okay, no, I am not even doing that. I simply call this add function. So I will write like HC is equal to need of this also. We simply call this add function. That's it. I'm calling this add function and then I'm printing it. Okay, and here we will return. Now I'm writing our add function. Now here what happens when you are trying to return the value or address. First we'll simply write this program stating int c is equal to a plus b and return c. Now here two things. One is this c and this c doesn't matter. Why? Because the scope of this c is this braces and the scope of this c is this function. So this will not affect this value. Okay, it will be allocated to different memories. So we need not worry about whether we have a variable. It's better to avoid it, but if you take the same variable name, then also there is no problem because the scope of this variable is different. Okay, so this should, what this is doing, we will see now. Then we will make changes to this program for pointers. So simply we have written one program, we are calling add function, and here we are passing some values to a and b, and we are returning the value of c. Okay. So now we will make the changes to this program now. So our output has to be 6. So the value of c is 6. Now we will make changes to this program. Now what I want to do is I want to make this as a pointer function. Okay, so when you are doing this like pointer function, at that we will do one more experiment with this. Okay, I'll just do one more thing. Okay, before making it a pointer function, I'll use one more keyword called static. Okay, so here what I'm doing is I'll just make this like c plus a plus. Okay, here I'll just make this variable initialized to 0, and after that what I'll do is c is equal to a plus b plus c. Okay, so if we do this now, we will run this program 2 times and see what happens. Okay, we need to run it without exiting. If we run, then only we will be able to see this static value. Okay, fine. Now the value of a is 6. We will try to do it with exiting the value. So here if I specify this as, but I don't know whether this will work or not. Let's save. Okay, so here I'll say you one point which is the important question in your interviews, and that is what is the keyword static doing here. Okay, so when we run continuously without exiting the program, at that time what happens here is the value, when you write static and we have written c, so at starting what was the value of c is 6, right? Because this is 0. 0 plus 5 plus 1 is 6. So without exiting, without executing it again, if at all, if it is continuously running, so once it comes out of this function, all the variables here a, b and c get collapsed. Okay, so the variables will be deleted. But when you write static, at that time this c variable will be there in the memory. It will not get deleted. So even when you call the function again, at that time c will retain its value 6. So when you run it again, or when you call this function again, at that time the value will be, okay, we'll do that here once again. We will try to execute it once again. 2 times we will call this function and you'll be able to see this. This is very important questions. That one of the questions they will write is what is the use of static keyword. Okay, so one thing you have to understand that when you are calling this add function, it will create 3 variables A, B and C. Okay, so when the control again returns to main function from add function, at that time your addition function variables will be deleted. So A, B and C should get deleted, and when again you call, it will allocate the memory. But now what happens, we will see, we are calling this addition function 2 times. So what should be the value of C 2 times, we will see now. Now if you see here, value of C is 6, and second time the value of C is not 6 but 12. Why it is 12 is because we have written the keyword called static. We will just remove this static keyword and execute it once again. We are calling it 2 times. Then you can just see this. It should show you 2 times C value only. C value is 6 only. C value is 6. Here the C value is 12. Why it is showing this is because of that static variable. We have written something like static in this. So what does the static do is, it is limited to this particular. When you are writing static keyword in particular function, it will retain that particular value. So when you call it again, the last value will be retained. That means when you are calling this addition function again, it will not create one more variable. See, because already we have created with the keyword static. Now this static keyword will be there for the whole program, but the scope of this variable will be only when you call this addition function. So when you call this addition function second time, at that time already the value of C is 6. That's why when you execute it again, 5 plus 1 is 6, 6 plus 6 is 12 at that time. Now again when you call this addition function, you will get some value like 18. But when you are not using this keyword, at that time C value will be 6 always. Okay, so that is the use of the keyword called static. Static retains its value. It will not delete the variable, but the scope of it changes. When you write it in main function or any other function or outside main function, the scope of this variable will change. Now when you call this in here, at that time, if you are not naming it as C and something like C1, and we are trying to fetch the value of it in main function, we will not get that value, because it can be used only in this particular addition function only, because the scope of this is this function. I hope it is clear. This is one of the use of static word, and it is not only used. Why it is used, what is the need of doing it is, we have seen some registers in 8051 microcontroller. Okay, so at that time we have seen something like RI, TI or any other flags which we used. At that time what happens, when you are calling that, or when you want to monitor that flag, like if you suppose 0 flag, and whenever 0 occurs, let me know. At that time what happens, every time the variable has to see that particular register, that whether the value of 0 has been reached or not, or the flag has activated or not. Every time this, if I am seeing, suppose I am writing something like this, okay, C is equal to some flag, I am just writing it, that's it. So here every time this C has to check this particular bit in that register, suppose PSW register. Now we are not writing any logic for this particular thing here. We are checking it somewhere outside, something is happening and we are checking that. Here there is no logic written for this particular flag. Okay, so what compiler will do is, it will try to make the things simple. So it will what you are checking it continuously, but there is no logic written here. So what it will do, it will simply delete, or it will check it once or twice and it will leave it. At that time it will not check it again and again because there is no logic written, but it has to check. So at that time, if we write this variable as static, and then what it will do is, even though there is no logic written in our program, it will say that this particular variable can change anywhere from outside. It can allocate any value, or it can assign any value from outside. So when you simply say this is something like static int, at that time, even though there is no logic written in your program, this will be checked continuously. Otherwise your compiler will just optimize this, that there is no action taking place, there is no logic to take action on this, and it will simply skip this statement. So if you don't want to skip this statement and you want to check it again and again, at that time you need to use static. So these are the two uses of static keyword. One is to let the compiler know that this variable can change anywhere from outside, even though the logic is not written in your program. And the second one is when you want to retain the previous value of any variable, at that time you will be using this static keyword. Okay, I hope it is clear why you are using static. Why? Because this is one of the important things we are using in your this is one of the important things that can be asked in interview. Okay, now we can do some operations also on your pointers. So we will see some more programs written. We will write some more programs and we will see. Okay, here I hope it is clear. So here we are writing one more program. second, this is not executed. I think. No, we have to write one. Okay, so here we will see one more thing, which is void pointer. Okay, so here what is this void pointer we will see now. Hash include here we are using something like I'm using one void variable which is void pointer j. Okay, now what is this void pointer? Void specifies that you are not specifying this variable to be used as a particular pointer variable. That means that we are not assigning it like integer pointer, character pointer, or any float pointer. We are simply saying that this is a pointer which can be used for any variable. Okay, so here if we write directly that j is equal to address of I, at that time it will throw us error. Why it will throw us error, I'll show you. So here we are assigning this j is equal to address of I, and then we are printing this printf. We will use this value of I is equal to %d backslash, and here I'll write pointer j. So it should print us the value of I, but it should throw us error. Now we will see what is that error and why we are getting the error. Okay, so here we are using one pointer called void pointer, and then we are executing it. So gcc. So as expected, here it is throwing us some errors, that expected expression before return and expected semicolon. Okay, these are the error, and missing terminating. Okay, fine, we'll just clear this first and then we will. Yeah, okay, here we have not. Okay, I think this is. Okay, and now we got some warning, and here we got this whatever we needed, that is invalid use of void expression. Okay, so here comes your typecasting. What is this typecasting? Is now when you are using a void pointer, we need to specify that what this you can use it. Like I'm using different variables, integer, float, or character, and I don't want to say that I want to use only one pointer variable that can be like sufficient for me, but I'm not specifying that whether it will be used for integer, float, or character. At that time we are using void. Okay, so now this one pointer variable can be used for integer as well as some character variable or some float. Okay, now we are using only one variable, but we will be specifying it for different ways. We are using only one. So if you are using this at that time, what we need to do is we need to typecast this. Okay, so here how we will do this typecasting. Here we have to specify that this variable is an integer pointer. So simply here what we will do, j is, we will write here this is an integer. That's it. If we do this, this should work. Okay, so here error is invalid use. Again we will see what is the problem here. So here what I'll do is, here also I'll write that this is an integer pointer, and we will see this. Still we are getting errors. And what is this? Invalid? No. This should not throw us error. Here also. Still we are getting errors. Somewhere we have written, actually these many typecastings are not required, but depending on compiler we are doing some error which we have to find it out. Just a second, I'll just check it out and I'll say okay. I think this will be sufficient, I guess, saying that it is an integer pointer. And we will see this now, whether this should work. Rather than specifying all these things, we will just write this here. This is a warning. Okay, that is all. That is fine, no problem. Now, yes, the value of I is something garbage value we are getting. Still we are getting some garbage value. Why we are getting this garbage value even though we should get this right? Okay, so here this is typecasting. We will see that why we are getting garbage value, but before that we will just see this, that here j here our j is a void pointer, and here we are assigning the address of an integer to it, and then while printing we are writing that print this value of j. It is okay, and it is a pointer pointing to an integer. Okay, but here we did one more mistake. What we did mistake is, here this is used for typecasting. Okay, so integer pointer points to an, it is specifying that whatever this pointer variable it is an integer pointer, which we have to declare it in 8th line. But in place of 8th line, now we are here, this whole thing we are replacing it with this particular thing, integer pointer. But now we will print one more value which will specify what is the value of this. This is printing address. So here we will do one more thing, and that is printf, and here I'll specify what is the value of I. So here this is replaced by this particular thing which is void pointer j, which is in place of void we are writing integer pointer, and then here we are writing this pointer to specify what is the value of I. Okay, and here we will simply write here p. Why? Because this is an address. Now it should not give any error, or it should not throw any warning. We will see that whether we are doing it, we are getting it or not. This is a pointer 4.3. Yes, we are not getting any error, and at the same time we are getting this correct value as value of I is equal to 1, as well as the address of here. Here why it showed us some wrong address is because we have written percentile D in place of percentile P. Okay, now the same thing here, we will make some changes to it, and we will do. Now after printing this particular thing, we will try to print the same variable, and so this particular thing, whatever you write, is called typecasting. Okay, it's not necessary that typecasting has to be done only on pointers. You can use typecasting on integer or float also. For example, here you can print it like while printing the value of character, or now float value is 9.87, right? So in place of this, I will simply print like printf value of T is equal to percentile C \n. And here what I'll do is, in place of this I'll write char what it is T. Okay, so here what that it will print. It should print 9.87, but in place of that it will print as something else. So here it is not showing us any value. That means here we have typecasted and it is not able to fetch that particular value. So here we can do it with this particular thing in bracket. We call it as typecasting. Whatever we need, we are just specifying or changing it according to that data type. Okay, now what I'll do is I'll simply take this particular thing and I will try to print the using same void variable. We will try to print the value of char as well as float, which will just make it clear that void pointers can be used anywhere. Now here j is address of y, as well as j contains the address of t, and here we will write it like there is no need to change anything here, but here we need to change this specification that now j is not pointing to an integer, but it is pointing to an char, and here also we need to change so that the address can be changed, and here we need to use float. Okay, this, I hope this will make you clear why we are using void pointers. If at all, if any other other things we will see, but as of now I can say that these are the basic uses of your void pointer. This is just a warning. Why? Because while printing the value of float, we are using percentile D, which is an integer, and this is nothing but double. That's why. But still, we'll just see. Okay. Now, if you see that Now you should see one thing, that is it is using same address location. It is not using same address location. Why? Because once it is used again, when you are assigning, it will just delete that and it will create a new one, or else even if it is there, it will be assigned a new address. Why it will assign new addresses? Because see, when you are writing something like I am assigning this void pointer variable to an integer, it is taking 4 bytes, and then when you are assigning it to char, it is taking 1 byte, and when it is assigning to a float, it will take, here it is taking 8 bytes. Why? Because we have not specified it. So here it will take it as 8 bytes. That's why your address will change, but the value will be same. Here we have specified that char value is 0, and here it will show us some garbage value. Why? Because here we have not specified it, that we are writing %d for pointer. Okay, so I hope this is clear for void pointer, that you can use void pointer to point any type of data type. You can use it with any type of data type, but with typecasting. Okay, so your typecasting will be done in this way. When you write int pointer j, so here this void pointer j will be replaced by this int. That means simply the void is replaced by this int, and when you write here pointer with this, then it will just to print the value. Why? Because generally when you write pointer j, it should print the value, but here we are using something like void. That's why we have to typecast it, and then we have to specify this pointer so that it will print the value, otherwise it will print the address. Okay, I hope this is clear. If it is clear, just ping me. Why? Because I'm not sure whether you are clear with this pointer as well as with static keyword, because these two things are very important for interviews.
Okay.
Right. So we'll go with next topic then. We will see one by one. We have dangling pointer, we have while pointer, we have null pointer. We will see one by one while writing program. Okay, so here now we will see some array concepts in it, and then we will see some more programs. Now, when you are writing an array, I think basics of array already we know that we are specifying it like simply we are writing, when you are using some array variables, what we will use, we will say array is nothing but group of same data type. Okay. If you are using some data type like char, int, or float, and if you want to use many things, many variables, at that time we are specifying it like int. Just a second. Now we will use this array. So here what we simply do, whenever we are using something like array, what we will do, int array, something like array of, if we specify 10, then 10 is equal to, either you can initialize it here itself, even if you don't initialize it here. This is the way of declaring an array, and after that if you want to initialize the values, then you can initialize, otherwise it will be initialized to 0. Now if you want to initialize it here itself, then we will say something like array of, and then we will write here some brackets or anything, like here you will give the values 1, 2, 3, 5, 7, something we will give. So this is the way of initializing here itself. And one more way, oh sorry, here we have to specify it here. I forgot to write here something, 9. Okay, so this is one way of initializing the array. If you don't initialize, it will assign it to 0. And the other one is, we need not, if we are initializing it here itself, and if we don't specify anything in this bracket, then also it will be considered like how many variables are declared, that many locations will be assigned. Okay, so here this dot is not dot, but this is comma. By mistake I have written dots, but this is one of the way of declaring it. Now here we have one thing, if at all if it is not specified, okay, if it is not specified, that it may contain garbage values also. And if you are now if I have declared 9 but I am using only 3, at that time what happens is the rest of the variable will be assigned to 0. And when you are saying array of 10, that means definitely it will be assigned to garbage values. But here when you are assigning 9, and when you are specifying using only 3 values, the rest of it like 0, 1 and 2 will be assigned for this array of 0, array of 1 and array of 2 will be assigned these values, but 3 to 8, that will be assigned 0. Okay, and suppose you are specifying only array elements of 2 and 1. At that time you have only 2 values, which is 0, or we will take something like 2. So at that time here the variables will be 0, 1 and 2. 0 and 1, right? 0 and 1. But you are specifying third value also. When you are specifying third value, then it may not throw any errors. Okay, it will not throw any errors, but generally array elements will be assigned contiguous memories. Contiguous memories in the sense, if you are saying that here the 1 is assigned with some memory location of 1001, at that time the next memory, here 1 is stored at 1001, then the next value is 1004, which is, as this is a 4-byte value, 1001, 2, 3 and 4. The next value, which is 3, will be located at 1005. And but here you have said only array of 2 elements. That means 1001 and 1005 will be for 1 and 3. But you are writing one more value called something like 6. So here we say 6. At that time this 6 is not specified. It may not be specified at 1009 or 1010. Why? Because here you are specifying only two memory locations. That's why it will be assigned only these 2. The third is assigned at this location or not, we don't know. It may be somewhere in the memory. It may not give us any errors, but it will not be at this contiguous memory location. So when you are trying to access it at that time, if it access something, if it access 1010, or if it is not able to access the particular memory location assigned, at that time it will throw us error. Even though it is 1010, your array elements are 2 proper values, but the third value may not be this 6. So in this case, to avoid all these errors, we need to specify how many variables. And if you don't know how many variables are there, just leave it blank and assign the values. Okay. Now, if we are using functions here, we will use this Or other than that, if you want to assign the values for integer, we are simply using a for loop stating that for I equal to 0. This is one of the way of assigning the values for I equal to 0, I less than 10, I plus plus, and we will assign the value something like array of I is equal to I. That means it will be assigning the value of I, array of I as 0 to 9 as 0 to 9. Okay, this is one of the way of assigning values to array using for loop, or here it is the way of assigning it directly. Okay, now we will assign it. We know already this by doing pass by value, or we can directly send it. If you call this for loop in your function, at that time we call it using pass by reference. Now how to do is pass by reference, because we are using pointers, so we need to see that. Okay, so here if we are using this using point, we need to use so our function name is something like int assign array variable. So assign underscore array, the values we are writing, and what we are passing is an not values, but we are passing address of the variable. So here we will write we are passing something like integers, and we have to assign that. Okay, and we will write definition. So we will write definition later. First we will write our main function now. So here in our main function, what we will do is variable something like I, and then we are using one array, and after using this array, we are assigning some values like 12, 45, 34, 78, and 67. Okay, and then what we will do here is we will use the for loop, and we will try to display these variables using the function called assign function. Okay, or here we will change the name. Oh, it's okay, assign, or we will say here the name is print, because we are print the array using this function. Okay, so we are not using anything any function or any variables in our print array function, but we are writing or assigning our array in our main function, and we are calling that from our print array function. Okay, so here we have I less than 5, because we have assigned 5 variables. So I less than 5, I plus, and here we will call our display function or print function. We are calling it like print underscore array. And now what we should pass in this way? Why? Because here we are specifying, we are calling this function 5 times, but what we should pass here, because we are passing simply a pointer, okay, which is an address of this particular array. So what we should point here? So what we will do is, here we will write the address of array of I. Okay, so here we are writing this array of I, and our function is finished now, and we will write our this function. We will definition function definition we will write now. So the function definition is, what we are doing here is nothing but we are simply printing. So we are taking one variable here, and that variable is something like R, and here we are printing it. So printf value of array. This is an integer, so I'm writing %d \n, and here we need to assign this pointer r. Okay, so what happens now is when you are calling this function, the address of this is assigned to r. Okay, so it should print 12, and after that it should print 45, 34, 78 and 67. Whether it is executing properly or not, we will see now, or it is throwing any errors or warnings. No errors. So you see, this is the way we are fetching the address of the array element. Okay, now by default, if you are not specifying this, then at that time, if you pass the address of variable once, at that time the base address, the first address of the array element is called base address. The base address of the array will be assigned. Okay, anywhere you assign to a pointer, the base address will be assigned. Okay, now we will see that using this increment operator, whether this is working perfectly or not. So here what we will do is we have to call this again and again, but how to increment this? Here we have to increment the pointer variable, but for that we need to pass, we will just try this. I'm not sure what I'm doing right now, but we will just call this function of print array, and here what I'll do is I'll here passing the pointer array element, and after that here I'm trying to write a for loop. Pointer r. Now here we are passing this as a array function, and what I'll do here is so here we are calling this function, and here we are using a for loop. But now what will happen is it will just execute it once. So what I'll do here is here I'll write pointer r plus plus. Okay, so we are incrementing our pointer variables. Let's see whether it is working or not, or we have done some error in this. So our output has to be same like the previous one. So it is okay, I is undeclared, so we need to declare the I value here. Why? Because it is declared in main function and not here, so we will declare it here. Okay, now it's not throwing us any error, so we will just execute it. Now segmentation fault we got. Why? Because again we are trying to access some memory location which is not in our reach. That means we have done some error here. So what is that error is? Okay, so here is the error. What is the error? We are trying to pass I value. Here we have not specified, we have not initialized I value. I might be anything. Now we are passing that I to your array. which is trying to have, now this I contains a garbage value, and you are trying to access your array with that garbage value, and that's why we are getting segmentation error. Okay, so here what we will do is simply we will remove all these things and we will try to write only address. That's it. Now let's see whether again we are getting this error. There's a warning. Okay. See, we are getting correct output now. Okay. So as I said here the output is now correct, but we are getting one warning, and that is here we are passing only one passing an address of only one variable, and that is your first or base element. Okay, but there is no problem with it. So in this way we are able to use this pointer variable. Now as I said, now if you say that here this is an integer pointer, and here if I specify this pointer as an char pointer, now what happens we will see. This is a char pointer, okay, and your values are an integer. Then will it show us the correct value or wrong value? We will try to see that.